To understand better about the concept, let us discuss the following problem. So, for instance, we have a reaction of what we call the sodium bicarbonate. So, NaHCO3 is sodium bicarbonate. We write down the symbol of a triangle like this. That means we are giving heat to it. And the sodium bicarbonate will form sodium carbonate and also carbon dioxide gas and water vapor. Okay? In a laboratory experiment, a student heats 42 grams of sodium bicarbonate and obtains 22.3 grams of the product, which is sodium carbonate. The question is, what is the percentage yield of this reaction? The first step that you need to do is to check if the reaction is already balanced. If the reaction is not balanced, then the first thing you need to do is make sure that you have a balanced reaction. For instance, in this case, you already have a balanced reaction, so you can proceed. The second thing is to make the ICF table. You have the initial, change, and final table. And don't forget that you have to use the mole as the unit. Now, in the problem that we have, what we know is the mass of NaHCO3, and that is 42 grams. First, we have to convert this into the mole value. So, from the data that we have here, 42 grams of the sodium bicarbonate, we can find the mole for sodium bicarbonate. We take the mass and we divide it with the MR of NaHCO3. You can check the AR for each of the elements in the periodic table, and then you will find that the MR is 84. So 42 divided by 84, you will get around 0.5 mole. Now, this is the initial condition. So you write down that you have a half mole of sodium bicarbonate starting this reaction. Because you only have one reactant, so of course this will be the limiting reactant, meaning that you will consume all of this 0.5 mole in the reaction, so you will no longer have the reactant. Now you have to calculate the mole of the sodium carbonate. How do we do this? You can refer to the last segment, and you can find the mole for sodium carbonate by taking the coefficient of sodium carbonate, which is 1, divided with the coefficient of the sodium bicarbonate, which is 2, then multiply with the mole of sodium bicarbonate. So here you get 0.25 mole, and from here you can find the mass of sodium carbonate by multiplying the mole of sodium carbonate with the MR of sodium carbonate, which is 0.25 multiplied by 106. You can find also this value based on the data that you can check in the periodic table. Then you will get more or less 26.5 grams. So this is what we call the theoretical mass. The mass of the product that you obtain from stoichiometric calculation. And according to the experiment, we know that we got less. So we only have, or in this case, this student, he or she only has 22.3 grams. While from the calculation, we are supposed to obtain 26.5 grams. So therefore, we can now determine the yield that is being asked in this question. The percent yield is the mass that is obtained experimentally divided by the mass that is obtained from the stoichiometric calculation multiplied by 100%, and you will get that the yield of this reaction is 84.2%. And this is the answer for this question.